All right, today we're going to study interior points in the set of Calculus 1. Let's focus on interior points. Let's start with A being a subset of the real numbers, and the definition of interior point is the following. We say that X is an interior point to A if there is an open interval A comma B, such that X is in A comma B, and that A comma B is a subset of A. The way I kind of like to explain this is the following. This is what I call an envelope. So we say that X is an interior point of A. If you can put X inside an envelope, and that envelope is inside the set A. You see what I mean? If A contains an envelope that contains X, you can say it like that. So let me just give you an example. Here is my set. Let me put my set A is this, I don't know, 2, 4. This is my set A. All right. So I would say that X is an interior point if there is a little A comma B that contains X, and that A comma B is inside of the black set. In this case, A is the black set. So who is an interior point? In this case, this guy right here, X is an interior point. And by the way, we denote the interior points with an A super zero like this. X is an interior point. This means the set of interior points with a little zero, all right? X is an interior point because there is an A comma B, an open interval, such that X is inside A comma B. That's my envelope. That envelope is inside the black set A. Take a look. Where is A and B in my picture? Where is little a and little b? Here is little a, and here is little b. X is inside A comma B, right? And that A comma B is inside my black set A. So that's why X is an interior point. Let me give you an example. Another example. X equals 0, 5, right? X equals 0, 5. So let's go ahead and draw it. 0, 5. All right, let's go ahead and draw it. That's my black set, okay? And so, oops, this means, hold on, let me make a little, this like a little 0. Remember, that's a little 0. This set of interior points, all right? So I'm going to check whether or not some points are interior, right? And I'm going to draw them in the picture. All right, let's go ahead and do them. So for instance, X equals 3, or like, let's just call 3. 3 is indeed an interior point. Why is that? Here it is. 3 is interior. Why? Because you can find an A and a B, right? This is my envelope that contains 3, and that envelope is inside the black set A, right? Let's do it again. This is A and B. That's my envelope. It contains 3. That's right. And that envelope is inside the black set. That's why 3 is an interior point. What's another interior point, Professor? How about 4? Yep, 4 is another interior point. Where is the A and B, Professor? Here is the A, and here is the B. Here is A, and here is B. Yeah, there is an A and B that contain 4, and that's inside 5. What's another interior point, Professor? Like 2 and 1 and like 1.03. Can you check 1.03, Professor? Yep. It's like somewhere here. 1.03. Here's an A, and here's the B, right? That contained the point 1.03, and it's inside the black set. What about 0.01, Professor? That's also an interior point here. 0.0, what is it? 0.01. Why is that interior point, Professor? Because you can find an A and a B that contain like an interval A comma B, an open interval A comma B. This is A and this is B, and that set A comma B is inside the black set. That's why that point is interior. Likewise, 4.9 is an interior point, and 4.99, that's also an interior point. Now, which points are not in the interior of a set? Here is I'm going to give you one that is not in the interior. X equals 0. 0 is not in the interior. Why not? Here is the picture. Why not? Here's the explanation. This point is not in the interior because if it were inside the interior, there would be an A and there would be a B, A comma B, that contains 0, right? And that whole interval is supposed to be inside the black set. So from here to here is supposed to be black, but it's not true because this piece is not black. There are points inside A comma B that escape the black set. That's why 0 is not an interior point. Likewise, 5 is not an interior point either. Can you explain why, Professor? Yep. Take a look. If this guy, X equals 5, were an interior point, there would exist an A and a B, a little open interval that contains 5, right? So that all this interval is inside the black set, but that's not possible because this part escapes the black set, right? The part on the right of 5, there will be points that are not in the black set. In fact, X equals 5 is not in the black set, right? So that's why 5 is not an interior point. So likewise, 6 is not an interior point, 7 is not an interior point, -1 is not interior. Like these points are not interior points. So what are yes, 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 yes. So what the heck is the set of interior points? Conclusion. The set of interior points, conclusion, here is the conclusion. Conclusion. The set of interior points is from 0 all the way up to 3, excluding 0, excluding, oops, hold on, did I say 3? How silly. It is 5. From 0 to 5, excluding 0, excluding 5. Thank you very much for watching that.